Number 2, ethene C2H4 has a molar mass of 28.1 grams per mole, may be prepared by dehydration of ethanol. So our reactant is the ethanol, and with the help of catalyst, we are forming the ethene, the alkene, and water. Remember, the dehydration reaction loses water, whereas hydrolysis will introduce water to break the polymer into monomers. Okay, they also gave us the molar mass of the ethanol, so that's quite handy here, instead of we finding these values in the periodic table. What else? Okay, we're given the delta H and delta S, so you can kind of predict that delta G is coming up soon. So I'm gonna write delta G is likely to come, and remember the formula of delta G is simply delta H minus temperature in Kelvin times the difference of the measure of the chaos, the entropy. Okay. Okay, if it's standard state, I guess I have to follow that. A student added 0.2 gram of sample of ethanol to a test tube here. Okay, that's the initial amount given that you start out with. And the student heated the test tube gently with a Bunsen burner until all of the ethanol evaporated and gas generation stopped. When the reaction stopped, the volume of the collected gas was, here's an important piece of information you need to know. Okay, let me use a red. 0.0854 liter, 0.822 atm, and 305 Kelvin. And also, it's very important to note that we are given the vapor pressure at this temperature. So anytime you see problem in free response, you're supposed to recognize the symbols that's gonna be used, and then you're supposed to come up with the right formula. So let's start with the symbols that represent the liter here. Clearly that's your volume, and 0.0854 liter. Okay. This is the volume of gas collected over here. You see the inverted, the test tube where ethene is collected. And then we also have a pressure. Now here's the tricky part. This 0.822 atm is a total pressure that's collected in this beaker or in this test tube. So I'm gonna note TOT because that's gonna be important later when we try to find the partial pressure of the dry ethene. ATM. And the temperature is 305 Kelvin, and we don't have to convert anything since it's given in Kelvin, so that's all nice and very neat. Okay, and then what about this guy? 35.7 torr at 305 Kelvin. That's the vapor pressure here, water vapor pressure. Okay, 35.7 torr. Notice that we're given the torr and we have ATM. We're gonna use PV equals nRT because we're given the volume, temperature, and pressure. We're missing the number of moles of, oops, okay, did not register that. Okay, number of moles of ethene. But we can't use the total pressure to get the number of moles of ethene directly. We still have to find the dry pressure or dry ethene pressure. So P C2H4 is P total minus P water vapor. That's because water vapor is making up some pressure in that inverted test tube. And the concept you need to be aware here is the Dalton's partial law of pressures. Dalton's partial law pressure. So whatever pressure each individual gas make up, when you add them up, that becomes the total pressure. So here we go. The total pressure is 0.822 minus, okay, here's something you have to be careful. 35.7 torr must be converted to in ATM. So I'm gonna divide that by 760. Okay, let me be more complete. So for those who are not familiar how to convert this, use a unit conversion. So I have 35.7 torr. Okay, that's the water vapor pressure. And if you want to convert it to ATM, because we're given the total pressure ATM and we have to use PV equals nRT, so we'll use a 760 torr on the bottom so that we can cancel out the torr. And the 1 ATM should be present on the numerator. Cancel that. And when I use my calculator here, 35.7 over 760, I get 0.0469. Well, I'm just gonna round up 0.4. Okay, 0. So 0.822 minus that value, I get 0.775. Okay, reason why I keep 3 sig fig is I have 3 sig fig after the decimal, and then I have a 3 decimal point. I have a 4 here. When you subtract 3 sig fig minus 4 sig fig when it comes to the subtraction, you gotta go with a smaller one. So we have to keep 3 sig fig here. Alright, so here's the ATM. Now we get to use the PV equals nRT, okay, to solve part A1. Okay, N equals, okay, PV should be up and RT should be on the bottom. Pressure we found was 0.775 ATM. The volume is, where is it, 0.0854 liter over the gas constant 0.08206 liter times ATM moles per mole Kelvin, and then the temperature should be 305 Kelvin. ATM cancel out, liters cancel out, and also the Kelvin cancel out. You know this is 1 over mole, but you have a big 1 over mole, so that becomes the mole. And when I perform the calculation, I get 0.00264 mole. So our answer to part 1 of A is 0.00264 moles. Keep 3 sig fig because we all have 3 sig fig here, and there's no addition in the PV equals nRT calculation, so here is the answer. Okay, let's be more specific. We're talking about the dry ethene.